So today we're going to be investigating ratios of sides in right triangles with specific angle measures. So what you're going to do is you're going to draw two triangles for each of the measures listed here. So you see 10 listed twice, 20 listed twice. So you're going to draw on paper two right triangles that have a 10-degree angle and an 80-degree angle, and two right triangles that have a 20 and a 70, 30 and 60, and so on. And then you're going to measure each side length individually, kind of based on where they are in the triangle relative to angle A. So you're going to measure the leg opposite from angle A, you're going to measure the leg adjacent to angle A, and then you're going to measure the hypotenuse. I've provided some sample lengths here that actually are accurate. So if you took these three segments and made a triangle that had those as the lengths, you would have a right triangle with angles 10 and 80, or at least approximately 10 and 80. Don't use these lengths, but this is just sample lengths that I provided. Okay. So what we're going to do with those, it's important that you measure them accurately, because when we look at a graph later, the graph should be the same as mine if you do it right, so you can kind of check your accuracy of your measurements that way. And the graph is going to be comparing several ratios. So we're going to look at the ratio of the leg opposite angle A with the hypotenuse, and we're going to compare that with the ratio of the leg adjacent A to the hypotenuse, okay, in a graph. So you could go through and you could calculate each ratio individually. So I could do 1.7 divided by 10 for the opposite leg and the hypotenuse, but that's kind of cumbersome. So my other option would be to kind of make an equation that says I want to calculate the leg opposite the angle divided by the hypotenuse for every one of these options, for every single opposite leg and every single hypotenuse. And I can do that with Google Sheets. Google Sheets is clever that way. So I'm trying to make an equation, and the way that I can indicate to Google Sheets that I want to make an equation is to type in the equal sign. So I type in the equal sign, and then what I'm trying to do is I'm trying to calculate the ratio. So I'm trying to divide the leg opposite A and the hypotenuse. And I'm going to use the backslash to represent division. And what you'll notice here is when I clicked on the cell, it automatically put it into the equation as C3, indicating that I'm going to use cell C3. Okay, and then I'm dividing it with a backslash by the hypotenuse, which is E3. Okay, so I've got C3 divided by E3, and then if I do that and I click enter, it calculates the ratio for me. If you look here, I actually have a fancy equation in here to figure out a side length. You're going to learn about that later, but that's why there's all these decimals here. So anyways, that's basically setting up an equation using cells that already exist. So I picked this cell and picked this cell and divided them, and that's going to be the equation. So what I can do with that is I can click and drag, and it fills in the column using the same equation but different values depending on where it is. So like if you look at in row 12, it's using C12 and E12. So Sheets kind of knows which it repeats the same equation, but it knows which cells to use. It kind of guesses what you want it to use. Or if I go to 18, for example, it's picked C18 divided by E18, and then it calculates that. So it kind of guesses what you want it to do. And then we can do the same thing for the ratio of the leg adjacent to A and the hypotenuse. So I can pick D3 and divide it by E3, and it calculates that. And then I can calculate the ratio of the opposite divided by the adjacent. So that's pretty convenient. So now we figured out all these ratios, and Sheets nicely filled in the columns for us using the equation that we created. So the next thing we're going to do is make a graph of all this data. So I'm going to go to Insert, and then Chart, and that's where the graph option is. And so what we have here is Google Sheets kind of looked at the data I put in and the way I arranged things and said, well, maybe this is the information that this person wants to look at in a graph. So they kind of created a graph for me based on what they thought I was trying to do. And this is kind of what I'm trying to do, but not exactly. So what I really wanted was a scatter plot. So I can go to Chart Type and pick a scatter plot. And then for my, let's see, so what does it say for x-axis? It says G20 through, or G2 through G20. And for my x-axis, what I really wanted was these angle measures over here. And you'll notice when I highlight those, it kind of fills in here. I could also type it in manually. So if I hadn't highlighted, I could still say A3 through A20. Okay, for my x-axis. And then for the y-axis, they use the word series. What I want to be doing here, and what you should be doing also, is comparing the two ratios, the first two ratios, so column G and column H. So we're going to type in, instead of H, we're going to type in G, and our data starts in row 3, so I'm going to pick G3, and it ends in row 20, so I'm going to pick G20. And then the colon indicates kind of G3 through G20 as my data. And then I also want to use column H, so I'm going to pick H3 through H20. And what I have now is a nice chart comparing column G with column H based on angle A. And so what you're going to do from here is you're going to take this chart, or this graph, and use the table, the values, and use the graph image to try to answer some questions that are in a Google Forms document here in this link. So that is a bit of how to make equations and graphs in Google Sheets, specifically with what we're trying to do with this activity.